Okay, section 11.2, arithmetic sequences. First, we're going to define it. When do we have an arithmetic sequence? We have an arithmetic sequence when the difference between consecutive terms is constant. So consecutive terms, meaning two numbers in a row, and constant, meaning it's the same. We call that difference the common difference, or D. So whenever we see the difference between these consecutive terms, we would call it D. And an equation to help us out would be D, which is that common difference, equals the second term minus the term before it. So if we look down at the examples, it's asking us, is this sequence arithmetic? And if so, state the common difference. So we're going to go back to this equation that they gave us and do the second term minus the term before it. Well, if our second term is 8, and we subtract the term before it, which is 2, that gives us 6. But remember, we want to know the distance is constant, if that difference is constant. So we're going to try the next term, 14, and again, subtract by the term before it, which was 8, and we get 6. And just to be sure, if we did it with the next term, 20, take away the term before it, you can see that we keep getting 6. So when they ask, is the given sequence arithmetic? We can say yes. And when they ask, state the common difference, we can say that D equals 6. And that problem is done. So for the second example, we're going to use the same equation. We're going to do the second term, which in this case is 45. We're going to subtract the term before it, which is 48. And you'll notice that we end up with a negative. That's okay. We may end up with negatives, we may end up decimals, we may end up with fractions. We're just looking to see if it's common, if it's the same each time. So now we'll go to the next term, which is 42. And again, we're subtracting the term before it, which was 45. And again, we ended up with negative 3. And if you did the same thing for 39 minus 42, you'd still get negative 3. So, is the given sequence arithmetic? We know that's a yes. And state the common difference. The difference is negative 3. We're going to do one more example. Using our last example here, is the given sequence arithmetic? So we're going to take the second term, which in this case is 5, and we're going to subtract the term before it, which is 2. That gives me 3. Now we want to make sure that's constant, so we're going to try it again with the next term in line, which is 7. We subtract the term before it, which is 5, and that gives us 2. As soon as we see two numbers that are not equal, we can stop and answer this question. No, it's not arithmetic. And there is no common difference, so there's no common difference to state. Now we're going to use some formulas, and today we're only going to do the explicit formula. So that is the formula that we're going to use. We use the explicit formula when we want to figure out terms in a sequence. So if you see a sequence of numbers and you see 3 or 4 numbers in a row and they're following that pattern, they have that common difference, but you want to know what it's going to look like way at the end, and instead of constantly adding that difference over and over, you can use the explicit formula to pick any term in the sequence. And so to go over it, we have some terms here. We have a to the n, which is the nth term. So if they tell you, for the example here, they want the 76th term, then n is going to be 76. That's the term they want. If they wanted the 20th term, the nth term would be 20. If they wanted the 50th term, the nth term would be 50. A1 is always the first term. So in this example given, 1100 is our A1 because that's the first thing they give you. And n is the number of terms. Now in this example, they want to know the 76th term, so again they want to know 76, so that's your n. And D is your common difference. They didn't give you the common difference, but we just learned at the top of the page how to figure out the common difference. Our equation for figuring out the common difference is still taking the second term and subtracting the term before it. So that's the first step in this problem, is find D. Okay, so I'm going to take the second term, which is 1,135, and I'm going to subtract the term in front of it, which is 1,100. And that's going to give me 35. Just to make sure we still have an arithmetic sequence, I'm going to check it with the other. 1,170 minus 1,135 also gives me 35. So we know that D equals 35. So we're going to go back and use the explicit formula to solve this. The explicit formula is still right here. So I'm going to rewrite it just for myself and say a to the n equals a to the first plus parentheses n minus 1, and those parentheses are very important, times d. Now we're going to plug things in. They want to know the nth term. The nth term was right there. They gave us to us. They wanted to know the 76th term. So we're going to say a and then a little 76 underneath it, which means that we're figuring out the 76th term. A to the first, or a sub 1, as it says up here, is the first term. So the first term in this sequence is 1100. So the first thing that we're going to plug in here is 1100. And then plus. And then we're going to fill in what's in parentheses. N, again, they said is the number of terms. And in this problem, they want to know the 76th term. So that means that there are 76 terms. So you plug in 76 for n, and we keep the minus 1. The last part is D, which we just solved for over here. D equals 35. All we have to do is solve this part of the equation. You can use your graphing calculator and plug in the entire equation if it comes up. So you can plug in your 1100, which was your first term. Didn't take the 11. Plus, and make sure you put your parentheses. We put in 76, which was the number of terms, minus 1, just like the formula said. And then again in parentheses, we're plugging in what we already solved for D, which was 35. Hit enter and let the calculator do the work for you. Now we have 3,725. So if we go back to our problem, they wanted to know the 76th term of this sequence of numbers. So if you counted that D over and over to the 76th time, your answer would be 3,725. If you complete this, remember tonight's homework is page 596, and you're doing 2 through 20 even.